For the last lecture in Unit 1, we're going to cover the law of conservation of mass and the law of conservation of energy. So Antoine Lavoisier discovered that matter is neither created nor destroyed in a chemical reaction. So when you have a chemical reaction, you have reactants going to products. And so the grams of the reactants will equal the grams of the products. This is what Lavoisier discovered. So let's look at an actual chemical reaction. The reaction we're going to examine is a combustion reaction that occurs in a lighter. So you have butane plus oxygen gives you carbon dioxide and water. So it's C4, and I don't expect you to know this formula, H10 plus O2, this triangle means heat, gives you CO2 plus H2O. So when you add up the reactants and the products, you should get the same total. So this is demonstrated with the butane lighter reaction. All right, so let's look at the next example. Suppose 12 grams of natural gas combines with 48 grams of oxygen in a flame. The chemical change produces 33 grams of carbon dioxide. How many grams of water form? So natural gas, even if you don't know the formula, you can still kind of arrange this in a reaction setup. The chemical change produces carbon dioxide and water. So 12 grams here, 48 grams here. So then we have 33 grams of carbon dioxide, and we want to know how many grams of water. So 12 plus 48 gives you 60 grams. So we know that we need to have the same total on the right side. So if I say 60 grams minus 33 grams, that will give you, so this is the total, this is carbon dioxide, CO2, and this would be the water. Okay? And this last one, a chemist forms 16.6 grams of potassium iodide by combining 3.9 grams of potassium with 12.7 grams of iodine. Show that these results are consistent with the law of conservation of mass. Okay, so your product is going to be potassium iodide. So we get 16.6 grams. And then potassium plus iodine. 3.9 grams. So when you add those together, you get that 16.6 grams. So that is consistent with the law of conservation of mass. So very good. Okay, so we've talked about the law of conservation of mass. Now we're going to talk about the law of conservation of energy. All right, so energy is the capacity to do work. And work is the result of a force acting on a distance. So the law of conservation of energy states that energy is neither created nor destroyed in chemical reactions. Okay, so kinetic energy is the energy of motion. So just a lot of definitions for you here. Potential energy, energy of position. Electrical energy is the energy associated with the flow of electrical energy. I'm going to say the flow of electrical, sorry, not electrical energy, electrical charge. Energy associated with the flow of electrical charge. Thermal energy is energy associated with random motions of atoms and molecules in matter. Chemical energy is a form of potential energy associated with positions of particles that compose a chemical system. So the units of energy, the SI unit of energy is a joule. A calorie is another unit of energy. 1 calorie equals 4.184 joules. This is a lowercase calorie. A nutritional calorie, like the ones you see in the nutritional information on food, is actually abbreviated with a uppercase C. And 1 big calorie is equal to 1,000 little calories. And the other unit of energy that you can see is the kilowatt hour. So if you look at your KCP&L bill, your electricity bill, you'll see kilowatt hours. Now we'll go through your usage and charge you for that. Okay, so the types of problems that you can see involving energy mainly are going to be conversion problems. So on the last page of the Unit 1 note packet, yay, I have a few conversion problems. So a candy bar contains 225 calories of nutritional energy. How many joules does it contain? So this is just a conversion problem like we did earlier in Unit 1. And a lot of students think, oh my gosh, it's different. It's not involving feet to meters or miles to kilometers. It's totally different. I can't do this. It's the same process. You have conversion problems. Your conversion factors, you're going to use those appropriately so you get your units to cancel out. So I want you to hit pause and try to set this up. Okay, so here's what you were given, 225 big cows. You're asked to find how many joules. Your roadmap, you're going to go from big cows to little cows and then to joules. So you're going to set your starting quantity, which has 3 significant figures. 3 sig figs. You're going to set that up as your starting quantity. You're going to divide. You're going to have the big calories on the bottom, so the little calories on top. And then you're going to use this conversion factor up here. So little calories to joules. And you end up with 941,400 joules. But you can only have 3 significant figures. So a good way to address this is to use scientific notation, or you could just say 941,000. You could just put 0, 0, 0. Okay, the next problem, again, is another conversion problem. I want you to hit pause, try to work through this, just like you did earlier in Unit 1. Okay, so you were given 512 little cows. You're asked how many kilojoules. So your roadmap is going to go little cows to joules to kilojoules. So 512 times 4.184 divided by 1,000. So you end up with 2.14 kilojoules. And remember, when it's on the bottom, you're going to divide. So 512 times 4.184 divided by 1,000. You end up with 2.14. And check your sig figs. You have 3 sig figs. And your answer has 3 sig figs. So if these conversion problems gave you a little bit of trouble, go back, review your conversion problems. it is never a bad idea to work your homework problems more than once. And I especially encourage students to do that before your exam. Because it turns out when you take your exam, or when you do homework problems, even though you've done it like maybe 2 days ago, you might forget. When you get to the point where you've done the problems over and over again and you're starting to remember how to do them, that's a good sign. So I was astonished when I started doing my homework problems 2 and 3 times before exams. I don't remember how to do this. I completely forgot. I'm going to have to think about that. It's good practice for the exam. So this concludes Unit 1. I will put a Unit 1 review up for you on D2L. Keep in mind that this review it's not the end-all be-all. If you do the review, it does not guarantee that you're going to get 100% on the exam. If you do pretty well on the review, it's a good sign, but I would redo my homework problems too. I'd redo my notes. I would, if there's something that you're not getting, rewatch the lecture. The more you put in, the more you're going to get out of this class. And if you want to do well in Chem 122 or Chem 124, you're really going to have to give it your all. So that concludes Unit 1. If you have questions about any of the content, please ask me in class. Keep your Post-it notes beside you. Write a little summary, questions. So you can ask me. Come by my office hours. Go by the SRC. Go by the Academic Achievement Center. All of us would love to see you, especially before you take an exam. Don't wait until it's too late. Don't wait until the day before the exam because it can be hard to cram. But consistently work through and consistently ask questions. All right, until next time.